Welcome to EDU World Space.
We're given a table, which I've reproduced for you below, of resistance versus length. And in particular, there's a spider thread that some researchers had, and they stretched it by 1 millimeter increment and then let it relax back to its original length. And they measured the resistance as the thread, the spider web, is being stretched. And so I've reproduced the table that's given here. And in question 80, we're told that if the conductivity of the thread results from the aqueous coating only, how does the cross-sectional area of the coating compare when the thread is 13 millimeters long versus the starting length of 5 millimeters, and assume that the resistivity of the coating remains constant and that the coating is uniform along the thread. And then we're asked to find basically how the cross-sectional area of the 13 millimeter length thread compares to the cross-sectional area of the 5 millimeter length thread. So we're told to actually use the starting value because there is an end value associated with the 5 millimeter length. So the values that we will consider in this problem are circled in red. And the equation that I'll be using is that the resistance is equal to resistivity times length over cross-sectional area. But to make things very clear, I will label with subscript 5 and 13, which will correspond to the length 5 and the length 13. So we have resistance 5, which is equal to rho L5 over A5. And when the thread is at a different length, we have R13 is equal to rho L13 over A13. And what we can do here is pretty much divide these two equations, or you can do this the long way, which is to solve one for rho and then substitute it into the other. But it's pretty short if you just divide them. So that's the approach I'll take here. So I have R5 divided by R13. That is equal to rho L5 over A5 divided by rho L13 over A13. And that cancels out, and that leaves me with L5 over A5 times A13 over L13, which is equal to L5 over L13 times A13 over A5. And I can go ahead and still rearrange this a little bit more because we want to find A13 in terms of A5. So if I move this stuff, L5, L13, and A5 over to the left side, so then I have A13 is equal to L13 over L5, R5 over R13 times A5. And these were given. L13 is literally 13 millimeters, and L5 is 5 millimeters. And we have from the table the corresponding resistance at these lengths. So we have A13 is equal to 13 millimeters over 5 millimeters times 9 times 10 to the 9 ohms divided by 102 times 10 to the 9 ohms. And then that's multiplied by A5. And this number is 117 over 510 A5, which is about 0.23 A5. Well, actually, I rounded up, so you put an equal sign here. And 0.23 is about 0.25 A5, which is 1/4. So A13 is about 1/4 A5, which is option B. So that's choice B.